Hi everyone. In this tutorial we're going to talk about fractions. First thing is that we've got three different types of fractions that we're going to look at today. Proper, improper, and mixed. So first of all we're going to go over proper. And the formal definition of a proper fraction is a fraction that has a value that's less than 1. A clearer way of looking at this is that it's the numerator's value, which is the top part of a fraction, is smaller than the value of the denominator. So, for example, I'm going to have a fraction bar here. So if I have 3 in the denominator here, I just have to pick a number that's smaller than 3 to be on the top, and it makes it a proper fraction. So a third. If I have a denominator of 10, it just needs to be smaller, so maybe 9. Those are the examples of proper fraction, and they are the most used fractions in all of mathematics. An improper fraction is one whose value is greater than 1. In other words, the numerator is bigger or larger than the denominator. So again, if we go into an example here, if we use the fractions from above, if I pick 3 for the denominator, I just have to pick a value that's greater than that to be the numerator, and it's automatically an improper fraction. And the reason is because this number in the denominator can fit in to the numerator. We'll get into that a little bit later on. So let's do another one real quick. If we stick with 10 for the next one, I could pick 98 as the numerator, and that is still improper. Now, a mixed number is a combination of a whole number and a proper fraction, but it always starts off as improper. So, for example, if we stick with 4/3 from above, okay, so in order to make this a mixed number, I need to figure out the total whole number of times 3 here will fit into 4 without going over. Now, you learned how to do this previously, so I'm not going to go into the mechanics of this. But 3 goes into 4 one whole time. Okay, so if I were to rewrite that and take 3 from the numerator, because I just took it out there, then I would be left with 1 in the numerator, and the denominator stays the same. This is the mixed number. Notice that there's a whole number, that's the 1, and then we have the proper fraction, the 1/3. So those are the different kinds of fractions that we're going to be looking at. So the next thing that we need to discuss then are factors. All numbers have factors. Basically, a factor is a product of two numbers that make up another number. For example, if I pick the number 10, okay, that's our number. What two numbers, when multiplied together, give me 10? Well, there's a couple. We've got 1 times 10, and we have 2 times 5. Each one of these numbers, 1, 10, 2, and 5, are all factors of 10. So let's do another one. What about the number 40? This one's going to have several more. We've got 1 times 40. 40 is an even number, so I know that 2 can fit in, so 2 and 20. I know 4 times 10, that gives me 40. I know 5 times 8, that also gives me 40. And those are the factors. So 40 has 8 factors. Now the reason why factors are important is because if you ever run into a situation where you need to reduce a fraction, you need to know this skill. Now along with factors, we also have prime factors. And it's pretty much the same thing, except we're only looking for those factors which are prime numbers. Now keep in mind, the number 1 is not prime. Okay? 2, however, is prime because its factors are 1 and 2. Okay? Both of which are prime. They're only divisible by itself and 1. 1 is funky. There's a proof out there that shows that 1 is not prime. If you don't want to look it up, it's fine, but just know that that's fact. 2 is actually the only even prime number that there exists. 3 is prime. Its factors are 1 and 3. Okay, 1 and itself. The number 19 is also prime. It's times 1 and 19, both being prime numbers. So those would be considered prime factors if the combination of 2 other prime factors make up another number. So let's see how to do this in an example. So we're going to have a few different parts to this, but we're going to write each number as the product of prime factors. So if you haven't heard of a factor tree before, that's the method that we're going to use to help break this down. And basically what you do is you just start this off by having two lines coming down. And I want you to think of a product that gives you 35, whether they be prime numbers or not. And actually, when I think about this, I can only think of two besides 1 and 35, because that's not going to really help us break this down. All I can think of is 5 times 7. So now, after you break that down, examine each value. What we want to do is find any of the prime numbers. Now, 5 happens to be prime, and 7 happens to be prime. Now, if all you're left with at the end are prime numbers, you're done. So the product, or I'm sorry, the answer to this question would be 5 times 7. That is how you write this number as the product of prime factors. So let's take a look at another one here. Let's do the number 24. So again, we're going to start this out by having two branches at the top. So again, I don't want to use a 1 and 24 because that's not very helpful. But I know that 24 is even, so I can break this down into 2 and 12. So let's examine each value. Is 2 prime? The answer is yes. So this part of my branch is done. Is 12 prime? No, it's not. It's composite. Composite just means it has more than one pair of factors. So let's break 12 down as if that were our beginning number. So the numbers that go into 12, well, I can think of 2 and 6. Okay, and again, examine each value. So 2 is prime, that part of the branch can stop. But 6 is composite, so that also needs to be broken down. And 6 can be broken down into 2 times 3. Now, we've actually reached the end because both 2 and 3 are prime. So look at all the values that we have circled. Whenever you write your answer, you always want them to be in order from least to greatest. So I've got 2, this one here, so 2 times, oops, that is an ugly looking 2, I'm sorry about that, and then another 2, and then times 3. And that is how you write 24 as the product of prime factors. Let's try one more. Let's do 45. Now, if you want to pause this video to take your to see if you can do this on your own, please give yourself that challenge. See what you can come up with and see if you can get the right answer. So what we're going to do is break it down. There are my branches. Let's see. I know 5 and 9 give me 45. 5 is prime. This part of my branch is done. 9 becomes 3 and 3. Now both of those are prime. So I am done with my factor tree. So in order from least to greatest, I've got 2 3's that I need. So 3 times 3 and then times 5. Now, you guys can use the check marks to help you keep organized as to which numbers you've already used, or you can put X's through them like this. Whatever way that you can find that helps you keep this really well organized is perfectly fine. So the last thing that we're going to take a look at is how to reduce a fraction into its lowest terms. Now, reducing means to take away any common factors between the numerator and denominator. Now, in order to do this, you can make factor trees of both the numerator and denominator, or you can just kind of guess yourself, and it's okay to do a guess and check. Now, when we take a look at this particular problem, I know that both 12 and 16 are even numbers, and therefore they are both divisible by 2. So what we can do is we're going to divide both the numerator and the denominator by this common factor, the common factor of 2. When I do that, let's see, there's my fraction bar. 12 divided by 2 is 6, and 16 divided by 2 is 8. Now, you may have your final answer and you may not. Some of these take a little bit of work to get really good at, but just keep practicing and just keep trying this method. So between 6 and 8, is there a common factor? And the answer is yes, because they are both even again. So I can do divide by 2 again, divide by 2 again, And 6 divided by 2 is 3. 8 divided by 2 is 4. So now again, examine your fraction. Do 3 and 4 have any common factors? And the answer here is no. This is the fully reduced form of 12/16. Let's try another one. So how about this one, 10/15? So what do they have in common? What number is a factor of both 10 and 15? The only thing I can think of is 5, so I'm going to divide both the top and the bottom by 5, which will give me a 2 and a 3. So let's think, do 2 and 3 have any numbers in, or any factors in common? And the answer here is no, and you can actually do this automatically if both the numerator and denominator are prime numbers, which they are. I mean, the only exception is if they were the same exact prime number. For example, 3 over 3, because anything divided by itself is 1. That's your exception. So this is our final answer here. So we're going to do one more, and then we are going to be done with this. So let's do 15 over 45. Again, with these two numbers, the only common factor that's really coming to mind is 5. If you happen to know that there's another one, you can use it, and that's okay. Those of you that are still practicing knowing your factors, it's pretty common that you're going to start with the smallest common factor that you know, and that's fine. The more you do this, the more you'll get to know those bigger common factors to make this process quicker and faster and easier. So 15 divided by 5, that's 3. 45 divided by 5 is 9. So 3 and 9. Any common factors? Yeah, they both have 3 in common. So I'm going to go ahead and divide each of these by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. And if you look at here, we've got 1 and 3. Both are prime, which means I am done. So that's your fractions. Thank you guys so much for watching, and stay tuned for the next one.